There we go. Okay, today we're going to start chapter 3. We are just going to hit like a few lessons in chapter 3. There's not a lot that we have to go over, but this would be one of them because it does kind of hit some important things, specifically how to express ordered pairs as like a table, mapping, a graph, things like that. Some of this you all have seen before, so it'll be pretty simple. And then we'll also talk about domain and range. Did you all talk about domain and range at all last year? Did somebody say yes?
Nope.
Nope. Okay. No worries. All right. So first, we need to know what a relation is. A relation is just a set of ordered pairs. Now, we all know what an ordered pair is. Agree? Somebody tell me what's an ordered pair. How do we see an ordered pair written? Always inside of parentheses. And what two values are represented in an ordered pair? X and Y, right? So you might write that somewhere in your notes. Right, X, comma, Y is going to be how we get an ordered pair. We're not going to have to write this every time, you guys. I just need you to know it for the first one. Okay, it is important that you write this down, at least our first example, because on your work today, you're going to be doing these same things. You're going to express the ordered pairs as a table, as a graph, as mapping, and then we will state domain and range. And I will label everything that I do. So the first thing we're going to do is make a table. A table is just a set of X and Y values. Sorry, I should have given you the, let me give this first. I'm going to move to a different page just so I have room to do this. But is everyone good writing with these directions? Okay. All right, so number 1. We have 2, 1, negative 1, negative 3, 0, 2, and negative 3, 4. Those little squiggly brackets just tell you that it's a set of numbers, okay? So we have 4 ordered pairs here. The first thing we're going to do is a table. When we make a table, we basically just make an X column on the left and a Y column on the right. And then you just need enough blanks. Like, it doesn't have to be perfect, you guys. Most of the time, you'll kind of see it look like this. Like, they'll put a box around. And then they'll just draw so you have spaces to write your answer. Okay, then all I have to do is list the ordered pairs in that table exactly how I see it. What's the first ordered pair that they gave me up top in that set? 2, 1. So all I do is write 2 in the X, 1 in the Y, right? And then I do that for every other ordered pair. What's the next ordered pair? Negative 1, negative 3, 0, 2, negative 3, 4. Okay, simple enough. Yes? Table's the easiest one. You just copy it down exactly in the order that you see it. You don't have to do anything special. Now, I do think you all have graphed ordered pairs before. Do you agree with that? Yes?
Yeah.
Okay. Somebody besides Phil, tell me how I would graph the ordered pair 2, 1. Can anyone tell me? Raise your hand and tell me how we would do it. Alden? Where do you start always?
The extent.
Yeah, at the origin, right? How would I graph 2, 1? Tell me what direction I would move. Go where?
Right over 2.
Right 2, and then up 1. Good. Right 2, up 1 is going to be my first ordered pair. We move left and right for x, up and down for y. Okay? Somebody else tell me how would I graph -1, -3? Go for it.
You move 1 to the left, and then down 3.
Good. 1 to the left, 3 down. Put my point. Now, what if my x value is 0? Do I move left or right?
No.
No, I just go where?
Down. Up.
Up how many?
2.
Up 2. Good. Okay, last one. -3. Left 3 or right 3? Left, and then up how many?
4.
Up 4. Okay. This is going to be the one that's the most new that we probably haven't seen yet. Okay. Mapping just takes domain, which is your x values, and maps it over to the range. Okay, so basically what we're going to do, I think the easiest way is just to draw 2 rectangular boxes. I know mine kind of fixes it for me. I didn't do a very good job. And we're just going to put them right next to each other. Now, we're going to write definitions for domain and range in just a second, but domain just refers to our x values, range refers to the y values. Now, the one thing on this, we're going to put, we don't repeat numbers. Now, on this example, I don't think any of our numbers repeat, right? When I look at my x values, I have 2, -1, 0, and -3. Did any of those numbers repeat? No. So I just need to write each of those down. And you don't have to go in a specific order. I just write them how I see them. Okay? Do any of my y values repeat? 1, -3, 2, and 4. So I just write them how I see them. Okay, if they repeat, you only write them one time, okay? Which we're going to do a second example on this, specifically on mapping, okay? Because I think this is the one that's new to us. All you have to do from here is match the domain to the range. So on this, I just draw an arrow that matches up the ordered pairs. Okay. Do we all agree we're capable of doing these things?
Yeah.
Really, you're not even have to actually doing any math today, which I know some of us will love, right? Okay, last thing is we have to talk about domain and range, okay? So, domain, which is my x value, range would be what value? Y. We list least to greatest every time. And we don't repeat numbers. Okay, now you guys should be able to still see your mapping, right? So we're going to look, you're looking at this right here. If I'm listing these numbers least to greatest, what am I putting first? -3, -1, 0, 2. So you're going to write that down. -3, -1, 0, and 2 inside your little squiggly brackets. Every time we list domain and range, we put these brackets to show what we were representing. So those are my x values. What would be my y values listed in order from least to greatest? 1, 2, 4. Okay. Now, I am going to do another example because this one didn't have any that repeat. I do want you to see an example with some that repeat so we know how to do those two things. Okay? All right. Any questions on this part? Still see a couple people writing, so I'm going to wait just a second. Is everybody okay? All right, number 2. Now, again, on this example, just for time's sake, I'm going to skip doing a table and the graph because I think those two are the easiest ones and you guys are good with those. They're not brand new to us. So we're going to do mapping first. All right, when I list my domain, my x values, do any of those numbers repeat?
Yes. They're not.
No, not on the x, right? So I can just list them how I see them. 2, 0, 3, and -3. What about on the range?
Yes.
Which one repeats?
-5.
So all I have to do is write 0, 4, and -5. Okay? Now, do I still have to draw arrows to match up the ordered pairs? Yes. Where does the 2 go to? 2 goes to 0, 0 goes to 4, and what do both 3 and -3 go to? Both of them go to -5. Okay? So that's the only difference when a number repeats. It'd be the same idea if it was an x, they would just go to 2 different ranges. Okay, who can tell me how to list my domain?
From least to greatest.
Least to greatest.
-3, 0, 2, 3.
2 and 3. Good. The only difference, you guys, from mapping to domain and range is you have to put it in order from least to greatest. Okay, we still don't repeat any numbers. What would I write for my range? -5, 0, 4. Good. Okay, do we all feel like we can handle this? Anyone have questions on the stuff I've done so far? Okay, I'm going to wait just a second. I still see a couple people writing here. One more thing we got to talk about before we're done. Am I okay to switch or anybody still writing? Okay. Okay, when we talk about analyzing graphs, there's 2 things we're going to do. We're going to talk about independent and dependent variables, and then we're also just going to talk about like what might be happening in the graph, okay? So first, independent variable. So independent is always going to be your input, which is an x value, okay? The input determines your output. Okay, Independent, which is always our x value, that's important for us to know when we look at a graph, determines the output. Okay? Dependent, if independent is your input, what would dependent be? Output, which is what variable? The y. Good. And this depends on the input. I'm going to talk about this more when we see the graph, because sometimes seeing the graph will kind of help us figure that out. Okay? Independent is our x value. Dependent is our y value. Independent always determines what happens with your output. The output depends on your input. Okay? Am I okay to go?
Yeah.
Did you say no, Trip?
Yeah.
Okay. Let me know when you're ready.
You go.
Okay. All right, here's our first graph. This is going to be distance and time. Okay, so this is giving us a graph of track practice, runners running during track practice. What value is represented by time? X. And what is represented by distance? Y. Okay, so knowing that, what would be our independent variable? The X, which is what? Time. So time is our independent, which means our dependent would be distance. Okay, what that's telling us is the distance that we run is depending on how long we run, correct? The more time we spend running, the further you're going to run, okay? Now, can someone look at that graph and tell me what was happening?
Like they started running and then they stopped and then they started running again. And
Yeah.
they slowed down.
How did you know they stopped, Killian?
Because it was just flat.
Yeah, this right here tells us they took some kind of break, right? So they were running for a period of time, they stopped and took a break, they started running again. What happened here to make this go a little slower? Slowed down, okay? So when it asks you to describe a graph, that might be what you say. Or you could say something like, as time increases, what happens to the distance? Distance increases, right? Because you might see some questions like that, possibly on your quiz that we're going to take next week. As time increases, distance increases. Fair enough? Okay, last one. Let me just go and put it on this side so I don't do a new page. I'm going to put I for independent, D for dependent. What would be my independent variable here? Hours, because it's what value? X. That means dependent would be paycheck, right? Now, this should make sense to us, especially if you ever worked a job, right? Does your paycheck depend on how many hours you work? Yes, right? If I work less hours, what happens to my paycheck? Less money. If I work more hours, more money, right? Now, someone tell me what happened in this graph. Truman, what happened? You just said it.
He started to get paid more.
Yeah, why do you, I know there's no way to really know this. Did anyone have an idea what would have caused them to get paid more? Overtime. Great answer. Yeah. We don't know that for a fact, but it could be they worked their normal hours, and then when they start working overtime, they pay you more money. Okay? Yeah. It could have been Tripp said something. What did you say, Tripp?
I said he got a raise.
Yeah, it could have been he got a raise or she got a raise, right? We don't know. But as long as the biggest thing I want is we can identify independent and dependent, and then you can look at a graph and just say what you just told me, right? Or as hours increase, paycheck increases, right? That's because always an acceptable answer. Okay? Do we feel like this is pretty good for today?
Yeah.
Okay. Any questions? Okay. You guys were great today. Thank you.